Imagine you're standing at a quiet intersection in the fading glow of dusk. Two streets branch away like the arms of an ancient compass, one leading to the familiar hum of home, the other toward an unknown sliver of night. Your footsteps hesitate. A single breath, a single decision, left or right. In that fragile pause, the world appears ordinary, but something deeper trembles beneath the surface. It is here between the inhale and the exhale that an unseen question waits. What if every choice you make doesn't simply close off possibilities, but lets them all unfold? Somewhere else, physics whispers an audacious possibility. The equations of quantum mechanics, so precise in predicting subatomic behavior, carry an almost mythic implication. Reality might not be singular. Each time a particle chooses a path, as if choice were even the right word, the universe might quietly split. Not in a violent shattering, but in a silent, ceaseless blooming. In one universe, the particle veers left, in another right, and both remain equally real. If the fundamental fabric of existence plays out in infinite variations, then your own moment of hesitation at the crossroads is not a simple fork in the road. It is a cosmic fracture. Consider the weight of that thought. The gentle sway of the evening breeze suddenly becomes a messenger of something enormous. In one world, you turned left and returned home early, perhaps never knowing what the other street concealed. In another, you turned right and met a stranger who changed the entire arc of your life. If the mathematics is more than metaphor, both stories unfold in tandem, two fates, neither aware of the other, yet both bearing your name. This is not idle speculation. In laboratories cooled to near absolute zero, physicists have watched particles behave as though every possibility is real until measured. Electrons dance like hesitant storytellers, tracing all conceivable paths at once, only collapsing into a single outcome when observed. And even that collapse, some argue, is not a collapse at all, but a branching of worlds, each containing a different answer. The double-slit experiment, that century-old riddle, still unsettles the sharpest minds. When a particle is not watched, it passes through two slits as a wave of possibilities. Observe it, and it behaves like a single, decisive traveler. Why should our mere act of looking change reality unless reality itself is more fluid, more layered than we dare imagine? To stand in that laboratory or even to contemplate it from afar is to feel an ancient vertigo. Human reason longs for a single stable universe, a singular chain of cause and effect. We like to believe the past is fixed and the future waits to be decided by the one life we inhabit. Yet quantum theory suggests a stage far stranger. Every potential outcome exists not as a fantasy, but as a living branch of the cosmos. What you call you may be one of countless versions, each carrying out a different sequence of decision. Pause and sense the unease this stirs. If every possibility is realized, then what becomes of the meaning of your choices? Does morality retain its weight if another you always chooses differently? Is triumph still sweet if another self stumbles into failure, or failure bitter if another self has already succeeded? Identity begins to wobble. The very phrase "your life" starts to dissolve, as if the boundaries that held it were only chalk lines on a cosmic blackboard, easily erased by a breeze of infinite variation. And yet, amid the vertigo, a quiet fascination grows. The idea of infinite versions of reality is not merely a threat to meaning. It is also an invitation. It calls us to reimagine existence as something vaster and more intricate than our habitual certainties. Perhaps significance does not depend on exclusivity, on being the only you, but on the very act of experiencing, of perceiving, of participating in the mystery. In this light, every decision remains intimate and personal, not because it locks other paths away, but because it reveals a particular window of the cosmos through which consciousness peers. Science and philosophy converge and collide here. The physicist's equations meet the philosopher's ancient riddle. What is reality? Are we actors in a single immutable script, or travelers through an endless forest of diverging paths? Some argue that quantum theory merely describes probabilities, and that talk of many worlds is an unnecessary flourish. Others insist that the mathematics, followed to its logical end, leaves no other option. Between these camps lies a tension as old as thought itself, the yearning for certainty against the recognition of mystery. Doubt becomes a companion. For every argument that multiverses must exist, another voice warns of speculation untethered from experiment. For every elegant proof, there is the stubborn fact that we have never glimpsed these parallel worlds directly. Evidence teases us but never settles the matter. And in that unresolved space, something profoundly human awakened, wonder. It is a wonder that does not comfort so much as provoke. It asks us to hold two truths at once: the meticulous rigor of science and the shimmering uncertainty that science itself reveals. We become witnesses to a reality that may be infinitely more abundant than our senses can grasp. The mundane act of turning left or right becomes a symbol of cosmic consequence, a reminder that what appears small may reverberate across dimensions we cannot yet fathom. This is the unsettling invitation to walk into a story where physics becomes philosophy, where the ordinary folds into the infinite, to look at your life not as a single thread, but as one luminous filament in a vast, unending tapestry. The next step you take, the next thought you entertain, may echo in worlds beyond imagining. And whether or not those worlds are ever proven, the possibility itself changes everything. Tonight, as the streetlights flicker on and the hush of evening deepens, you stand once more at that quiet intersection. The choice before you is simple, yet the cosmos, in all its silent multiplicity, leans closer, waiting. Quantum foundations, the strange bedrock of reality, step into the quantum realm, and the very language of certainty begins to fracture. The universe you thought you knew solid, predictable, ruled by clockwork, precision dissolves into a theater of probabilities, where particles are both something and nothing, everywhere and nowhere, until the very act of looking snaps reality into a single, fleeting shape. It is a domain where mystery is not a veil to be torn away, but the fundamental texture of existence itself. For centuries, classical physics gave humanity a sense of mastery. Newton's laws rendered the heavens and the earth into a majestic machine. Planets circled the sun as reliably as gears turning in a watch. A tossed stone obeyed equations so precise that its arc could be plotted before it left the thrower's hand. Determinism was the creed. If you knew the initial conditions of any system, the positions and momenta of every component, you could, in principle, predict the future as surely as you recount the past. Laplace imagined a supreme intelligence that, knowing all the forces and all the particles, could foresee every event across time. The cosmos, to this classical mind, was an open book waiting only to be read. Then came cracks in the machinery. By the dawn of the 20th century, light itself betrayed an ambiguity that refused to be tamed. Sometimes it behaved like a particle, carrying discrete packets of energy quanta. Other times it rippled outward as a wave, diffracting and interfering like a trembling pond. The double-slit experiment crystallized this tension into a single, unsettling drama. Fire electrons or photons at a barrier with two narrow openings, and a screen behind reveals a pattern of bright and dark fringes, the signature of waves interfering. Yet when these particles are sent one at a time, with no possibility of mutual jostling, the interference pattern still emerges, each solitary particle apparently interfering with itself, as though it travels both paths simultaneously, a ghostly superposition of possibilities. But place a detector to watch which slit the particle takes, and the pattern collapses into two simple clumps, the unmistakable footprints of particles choosing a single path. Observation, it seems, changes the very outcome. Here the quantum revolution announced itself. Reality, at its core, is not a set of definite properties waiting patiently to be discovered. Instead, it presents a field of probabilities described by the mathematical poetry of the wave function. Schrödinger's equation governs this wave function, predicting the evolution of these probabilities with unerring precision, yet it remains silent about which specific outcome will occur. Before measurement, an electron's position is not merely unknown, it is undefined, a haze of potentialities. Only when observed does the wave function collapse and one concrete reality crystallizes from the infinite. This principle of superposition stretches the imagination. A quantum system does not merely occupy one state or another. It inhabits every possible state at once, like a chord that contains all the notes of a scale, awaiting the musician's touch to select a single note to be heard. Schrödinger's famous thought experiment gave this abstraction a macabre edge. A cat sealed in a box, its fate tied to the decay of a single radioactive atom, exists in a liminal twilight, neither alive nor dead until someone lifts the lid. The cat's predicament is absurd, yet it mirrors the unavoidable implication of quantum theory. At the smallest scales, nature is not an unfolding story, but a branching novel in which every plotline coexists until our act of observation turns one into history. Wave-particle duality deepens the paradox. Electrons, photons, even large molecules, when cooled and isolated, exhibit the eerie ability to be both discrete particles and extended waves depending on how we look at them. There is no hidden switch deciding in advance whether they will reveal their wave-like or particle-like face. The context of the experiment draws out one aspect or the other. It is not that these entities alternate between being waves and being particles, but that our very categories fail to capture their true nature. The quantum world laughs at the tidy boxes of classical thought. Entanglement adds a final twist that defies the very notion of separateness. Imagine two particles born together in a single quantum event, then carried to opposite ends of the galaxy. Measure the spin of one, and the other's state is instantly fixed, no matter the distance. Einstein, famously uneasy, derided it as spooky action at a distance, suspecting hidden variables lurking beneath the equations. But decades of increasingly refined experiments, most notably the landmark tests of Bell's inequalities, have closed every reasonable loophole. The correlations are real, stronger than any classical mechanism can explain, and they unfold with a swiftness that seems to outpace light itself. Quantum mechanics does not allow faster-than-light communication, but it does suggest that at a fundamental level, the universe is woven together in ways our familiar notions of space and time cannot contain. The mathematics behind these phenomena is both austere and exhilarating. The wave function is not a physical wave in space, but a complex valued probability amplitude. Squaring its magnitude gives the likelihood of different outcomes, but the phase relations hidden in those complex numbers create interference patterns, the very fingerprints of quantum weirdness. Operators act on the wave function to represent measurable quantities like momentum and energy, and the Heisenberg uncertainty principle emerges not from clumsy instruments, but from the deep structure of the theory itself. Position and momentum cannot be simultaneously specified with arbitrary precision, not because we disturb the system by looking, but because nature itself resists such simultaneous definiteness. This is not a statement about technology. It is a law of reality. Contrast this with the reassuring determinism of classical physics. There, uncertainty stems from ignorance. In principle, better data always promise sharper prediction. In the quantum realm, uncertainty is not an accident, but a feature. No matter how perfect the experiment, no matter how complete our knowledge of the wave function, the result of a single measurement remains irreducibly unpredictable. We can predict statistical distributions over many trials with uncanny accuracy, yet each individual event is a roll of the cosmic dice. Einstein's lament, "God does not play dice," has become the emblem of his discomfort, but the experiment's answer in chorus. Yes, at least in the quantum domain, chance is not merely a mask for hidden determinism. It is woven into the fabric of being. This clash between classical certainty and quantum indeterminacy is more than a scientific revolution. It is a philosophical upheaval. The very notion of an objective reality existing independent of observation wavers. Are particles merely potential until measured? Does the act of measurement create the properties we observe? The Copenhagen interpretation championed by Niels Bohr accepts this as the ultimate lesson. Physics does not describe an independent reality, but our interaction with it. Other interpretations resist this radical stance. The many worlds view envisions every possible outcome unfolding in a branching multiverse, where the wave function never collapses but our consciousness rides a single branch. Pilot wave theories seek hidden variables to restore determinism, proposing a deeper layer where particles have definite trajectories guided by a quantum wave. Each attempt to make sense of the mathematics carries its own metaphysical weight, and none has achieved unchallenged victory. Yet amidst the debates, one fact remains unassailable: quantum theory works. Its equations describe with breathtaking accuracy the behavior of semiconductors, lasers, superconductors, and the atomic interactions that fuel both stars and human technology. The wonder lies not only in the strangeness of its predictions, but in their empirical success. Quantum electrodynamics, the most precisely tested theory in the history of science, predicts the magnetic moment of the electron to more than 10 decimal places, and experiments match it digit for digit. The universe, in its deepest operations, dances to a tune we can calculate but scarcely comprehend. Consider again the double-slit experiment, now refined with single photons, electrons, even complex molecules. No matter how massive the particle or how careful the controls, the interference pattern persists until we extract which path information. It is not merely light or electrons that carry this ambiguity. It is matter itself. The classical dream of a perfectly knowable universe falters before this quiet demonstration. Reality, when probed, does not yield a single narrative but a superimposed chorus of possibilities. Only when compelled by measurement does it choose a verse. This strange bedrock of reality invites both awe and humility. It challenges the comfort of a world fully knowable and forces us to confront the limits of human intuition. Quantum mechanics is not merely a set of equations. It is a new grammar for describing existence. It whispers that certainty is an illusion, and that the cosmos is less like a machine and more like a poem. Each measurement a stanza drawn from an infinite text. The tension between scientific rigor and philosophical mystery is precisely what makes this field so captivating. Evidence anchors the wonder. Laboratories across the world repeat these experiments daily, verifying the same paradoxes that startled the pioneers a century ago. Yet the deeper we explore, the more reality eludes the grasp of common sense. This is the quantum foundation, strange, unyielding, and luminous, on which all modern physics stands. Birth of the multiverse. Idea in the smoky corridors of mid-20th century physics. A quiet rebellion was brewing, one that would challenge the very notion of a single, linear reality. To understand the shockwave Hugh Everett set in motion, we must first step into the intellectual climate that surrounded him. Quantum mechanics had already reshaped the scientific imagination. It promised a universe ruled not by classical predictability, but by probabilities, a strange world where electrons flickered in clouds of possibility and light could masquerade as both wave and particle. Yet for all its triumphs, the reigning interpretation, the Copenhagen view, insisted on a peculiar bargain. The quantum world remained a shimmering haze of probabilities until an act of measurement forced it to choose. The Copenhagen interpretation, championed by Niels Bohr and Werner Heisenberg, was as much philosophical stance as scientific hypothesis. In their view, the mathematics of the wave function described not an objective reality, but our knowledge of it. When an observer measured a particle's position or momentum, the wave function was said to collapse, selecting a single outcome from a multitude of possibilities. Before observation, reality itself was indefinite. After observation, it snapped into a definite state. This bold, almost mystical position carried the weight of authority and the allure of a final word. Most physicists accepted it as a pragmatic recipe. Shut up and calculate, as the mantra later went. But for a young American physicist named Hugh Everett III, the idea of wave function collapse was a conceptual sleight of hand. To him, It was an unspoken admission that physics could not describe the entire universe, only the sliver we happen to observe. Born in 1930, Everett possessed a mind both mathematical and rebellious. He entered Princeton in the early 1950s, a time when quantum mechanics was maturing, yet riddled with paradoxes. Everett was struck by the elegance of Schrödinger's equation. It described how the wave function evolves deterministically, like a perfectly tuned symphony of probabilities. Why, he wondered, should this equation suddenly break down when a human chooses to look? Everett's insight was radical in its simplicity. What if the wave function never collapses at all? What if the mathematics of quantum theory applies universally, even to observers themselves? In that case, measurement would not reduce possibilities. It would merely entangle the observer with the observed. Every potential outcome would unfold, but in separate, non-communicating branches of reality. The universe, rather than selecting one future, would give birth to all of them. Such an idea sounds almost mythic, but Everett approached it with the cool rigor of mathematics. In his 1957 doctoral thesis, he proposed what he called the relative state formulation. Today we know it as the many worlds interpretation. In Everett's framework, when a quantum event offers multiple possible outcomes, say, the decay or stability of a radioactive atom, each outcome is realized, but in a distinct branch of the universe. These branches do not interact. They coexist like parallel melodies, each as real as the other. To an observer inside one branch, the illusion of a single, definite outcome remains. Yet beyond the observer's limited perspective, reality is an ever-branching tree of possibilities. Contrast this vision with the Copenhagen picture, a solitary universe punctuated by sudden, mysterious collapses. For Bohr, the act of observation was a fundamental, irreducible boundary. Physics could describe only what was measurable, and anything beyond was metaphysics. Everett rejected that boundary. If the equations work for atoms and stars, why not for us? To him, the notion of collapse was not merely inelegant, it was unnecessary. Everett's thesis landed like a subtle earthquake. While his mathematics was airtight, the philosophical implications rattled even seasoned physicists. Bohr, the elder statesman of quantum theory, met Everett in Copenhagen. The meeting was famously tense. Accounts differ, but the core conflict was unmistakable. Bohr insisted that quantum theory was complete only when wedded to the concept of measurement, whereas Everett maintained that measurement was just another physical interaction, no more mysterious than two billiard balls colliding. For Bohr, Everett's idea threatened to dissolve the careful boundary between physics and metaphysics. For Everett, Bohr's stance was an arbitrary wall built to protect a cherished orthodoxy. The reaction from the wider physics community was, at first, chilly. To many, Everett's multiverse sounded more like metaphysical speculation than serious science. Richard Feynman reportedly dismissed it as many worlds, many words. John Wheeler, Everett's thesis advisor and a physicist of rare imagination, tried to champion the work, but even Wheeler urged his student to soften the rhetoric. The physics world of the 1950s prized empirical modesty, and Everett's proposal, however mathematically pure, seemed to stretch beyond the reach of experiment. Everett himself was not the sort to wage a public campaign. After earning his PhD, he left academia for a career in defense research and game theory. For years, his idea lingered at the margins, a tantalizing thought experiment whispered among the adventurous. But like a seed buried in dark soil, it began to germinate quietly. The philosophical allure was undeniable. If the universe indeed branches at every quantum event, then every choice, every chance occurrence, spawns a multitude of realities. There is, in this vision, a strange consolation. Nothing is truly lost, and every path is taken somewhere. Physicists who encountered the idea wrestled with both fascination and doubt. Could such a grandiose picture be more than a mathematical curiosity? How could one ever confirm the existence of these hidden worlds? And yet, the very boldness of the proposal, its refusal to invoke mysterious collapses or privileged observers, was irresistible. Over time, a new generation of thinkers, from Bryce DeWitt to David Deutsch, began to explore and popularize Everett's concept. What had begun as a lone graduate student's rebellion slowly evolved into a serious contender in the ongoing debate over quantum foundations. The intellectual tension between Copenhagen's singular, observer-dependent reality and Everett's vast, branching cosmos remains one of the most profound contrasts in the history of science. On one side stands the comfort of a universe that selects one truth when we look. On the other, a dizzying vision in which all truths unfold, forever beyond our capacity to witness them all. Between these poles lies the enduring mystery of quantum mechanics, a mystery that continues to entice physicists and philosophers alike. Everett did not live to see his ideas full flowering. He died in 1982, largely uncelebrated by the mainstream physics community. Yet his proposal has since become a cornerstone of modern debates on quantum reality, influencing fields as diverse as cosmology, quantum computing, and the philosophy of mind. Whether the multiverse is a literal truth or a grand metaphor, Everett's defiance of orthodoxy reshaped our imagination of what reality might be. The question he dared to ask, whether the universe is singular or infinitely plural, remains as haunting and electrifying today as when it first startled the quiet halls of Princeton. The air of a modern physics lab carries a kind of quiet suspense, machines humming, lasers threading invisible pathways through vacuum chambers. Here, at the frontiers of measurement, scientists pursue whispers of realities that may or may not exist. They are not simply observing electrons or photons, they are stalking the very boundary between what can be known and what forever slips beyond the net of human inquiry. Consider the dream of quantum interference, not in tiny atoms, but in objects large enough to be seen by the naked eye. For decades, the double-slit experiment has stood as a shrine to quantum strangeness. Fire a single electron toward two slits, and an interference pattern blooms on the screen, evidence that each particle behaves like a wave, exploring multiple paths at once. Yet this marvel lives comfortably in the realm of the minuscule. The challenge, some would call it the Holy Grail, is to make the same pattern appear when the traveler is not an electron, but a molecule thousands of times heavier, perhaps even a microscopic grain of matter. If such interference could be coaxed from the macroscopic, it would be a breathtaking confirmation that quantum weirdness is not merely a trick of scale. It would say with quiet authority that the logic of superposition belongs to the very bones of reality. Step by step, experimenters have crept toward this dream. In gleaming apparatuses cooled to near absolute zero, enormous molecules, carbon cages shaped like soccer balls, clusters of atoms bound in delicate scaffolds are launched through double slits. Detectors downstream wait like patient hunters. And patterns do emerge, faint fringes of interference, fragile as a spider's web. Each success whispers that quantum law still holds, even when the particle is no longer just a lonely electron, but a miniature cathedral of matter. It is a triumph, but also a tease, because every increase in size makes the pattern fainter, the conditions harsher. To keep the quantum alive, one must silence the universe itself, shield out every stray vibration, every wandering photon, every breath of heat. This is the kingdom of decoherence, the quiet assassin of quantum superpositions. Interactions with the environment, motes of air, the tiniest fluctuation in temperature collapse the delicate wave of possibilities into a single, ordinary fact. Decoherence is not a villain in the usual sense. It is nature's own bookkeeping, the reason our everyday world appears solid and classical. Yet for those chasing macroscopic interference, it is an ever-present nemesis. Whole teams labor to tame it, suspending objects on magnetic traps, using cryogenic coolers to still atomic motion, even levitating nanoparticles in vacuum so that nothing touches them. Each technique buys a few precious moments of quantum coherence before the inevitable unraveling, and so the tension sharpens. On one side stands the mathematical purity of quantum theory, which insists that superposition has no built-in scale. On the other side looms the brute fact of decoherence, the universe's relentless tendency to nudge possibilities into a single outcome. This clash fuels a deeper question. When, if ever, does the quantum give way to the classical? Or is the classical merely an illusion born of our clumsy instruments and our need for definite answers? Measurement itself becomes a riddle. The act of observing a beam of light touching a particle, a sensor registering a position, seems to force reality's hand. But what, precisely, counts as an observation? Is it a conscious mind, a digital readout, the mere scattering of a photon? Experiments have sliced the problem ever thinner. Some arrange detectors so cleverly that the choice of measurement is delayed until after the particle has passed the slits. Still, the interference vanishes the moment the which path information becomes available, even in principle. It is as if reality cares not about when we look, but about whether the universe could, in theory, know. These studies of delayed choice and quantum erasure are more than intellectual parlor tricks. They are probes into the architecture of existence. They suggest that reality is not a simple film unspooling frame by frame, but a tapestry woven from possibilities, some of which wink out the instant they become knowable. For advocates of the many worlds interpretation, such results feel like an unspoken invitation. Perhaps every possibility persists, branching into parallel histories when observation selects one path. Yet for all the poetry of infinite worlds, no detector has yet clicked to announce a neighboring universe. The evidence is tantalizing but never conclusive, a shimmer at the edge of reason. Even the most ambitious experiments strain against the limits of technology. Instruments can measure to extraordinary precision distances smaller than a proton's width, times shorter than a trillionth of a second. Yet the phenomena they chase are subtler still. A single stray particle of dust, a whisper of cosmic background radiation, can ruin months of effort. Researchers speak of technical noise with a mix of frustration and reverence, aware that what they call noise may simply be the universe reminding them of its own inscrutable depth. It is here, at this delicate frontier, that the philosophy of physics turns almost existential. The scientist becomes both hunter and poet, chasing proof of a reality that may never consent to be captured. Each new experiment pushes the boundary of the knowable, and each failure to find a smoking gun of parallel worlds underscores a profound truth. Nature may keep some of its secrets not through malice, but through the very fabric of what it means to measure. Competing visions collapse as branching. Imagine the universe as a grand stage where reality itself is the elusive protagonist. The lights dim, the curtain rises, and four rival storytellers step forward, each holding a different manuscript of existence. Their scripts do not merely interpret the world, they redraw its very boundaries. Tonight, they debate how quantum possibilities solidify into the single experience we call now. First, the many worlds interpretation strides to the podium with quiet confidence. Its claim is audacious. Every quantum event spawns a branching of realities, each as real as the one you inhabit. There is no single collapse, no dice thrown by nature. Only an ever-splitting multiverse where every outcome is played out. Here, the mathematics of quantum mechanics is taken at face value. Schrödinger's equation never falters, never hides a secret mechanism of reduction. It is elegant, parsimonious, breathtakingly bold, yet its very grandeur provokes its rivals to challenge it. From the shadows emerges the doctrine of objective collapse models, an insurgent voice of realism tinged with caution. These theorists dare to suggest that the wave function, the mathematical cloud of quantum possibility, does not merely describe potentialities. It is a physical entity that occasionally snaps into a definite state, not because we look, but because nature demands it. Models like GRW, Ghirardi-Rimini-Weber, or Penrose's gravitational collapse whisper that at some critical threshold, quantum superpositions grow unstable and reality itself chooses. No need for a cosmic family tree of infinite branches. The universe trims its own hedges, but this act of trimming is not without cost. To postulate collapse is to weave new forces or triggers into the fabric of physics. One must explain when and how the collapse occurs, what invisible switch flips the quantum coin. To its critics, this is adding machinery without evidence, sacrificing mathematical purity for the comfort of a single world. Yet, to its defenders, it is a necessary honesty. Nature, they argue, is not an abstract equation but a dynamic arena where events happen. Collapse is not a flaw in the quantum script. It is the climactic beat that gives the drama meaning. Another voice clears its throat, steady, meticulous, almost conspiratorial. Bohmian mechanics, also known as the pilot wave theory, enters with the air of a hidden order. David Bohm envisioned a universe where particles possess precise positions and trajectories, guided by an invisible pilot wave. Quantum uncertainty in this telling is not a fundamental blur, but a reflection of our ignorance of those hidden variables. The mathematics of the pilot wave faithfully reproduces quantum predictions, but behind the curtain, a deterministic clockwork ticks. To the many-worlder, Bohmian mechanics seems almost classical, a return to a comforting determinism, yet it carries a radical twist, non-locality. The pilot wave whispers across space instantaneously, binding distant particles in a dance that defies the speed limit of light. Bohm's cosmos is a single, unified whole where cause and effect stretch beyond ordinary locality. For some, this secret choreography is deeply satisfying, a restoration of order. For others, it feels like an elegant contrivance, deterministic, yes, but at the price of a mysterious, faster-than-light conversation that can never be directly observed. Then steps forward a more subtle philosopher, relational quantum mechanics. Its champions speak with the quiet authority of those who question the very grammar of reality. Here, the quantum state is not an absolute description of an objective world. It is a story told from one system to another, an account of relations rather than things in themselves. Reality, in this vision, is not a single canvas, but a web of perspectives. An event is real only relative to an observer, and different observers may rightfully record different truths without contradiction. To the relationalist, asking what is the state of the universe is like asking what is the color of music, a category error. Quantum mechanics, they argue, has always been about the correlations between systems, not an omniscient narrative. This interpretation does not need collapse or branching because the very question of a universal wave function is misplaced. Reality is dialogue, not monologue. As these voices intertwine, the debate deepens into a duel of philosophical temperaments. Determinism versus randomness forms the first arena of combat. Many worlds and Bohmian mechanics both defend a kind of determinism. The Schrödinger equation, or the pilot wave, leaves no room for chance. Yet determinism wears two faces. For Everettian multiverses, every possible outcome unfolds, so probability becomes the measure of how often copies of you experience one branch rather than another. For Bohm, there is a single path, hidden but fixed, and probability emerges only from our ignorance of initial conditions. Objective collapse models plant their flag on the hill of genuine randomness. When a superposition collapses, the result is not preordained. It is an irreducible act of chance. Relational quantum mechanics sidesteps the duel entirely. In its perspective-woven tapestry, determinism and randomness are not fundamental properties, but contextual features of the conversations between systems. The next clash is subtler: ontology versus epistemology. Many worlds, with its infinite sprawl of parallel realities, offers a bold ontology, a vast metaphysical landscape where every possibility is real. Bohmian mechanics, too, insists on a hidden ontology, definite particle positions and guiding waves that exist whether we observe them or not. Objective collapse models modify the ontology of quantum fields, inserting a real physical mechanism that shatters superpositions. Relational quantum mechanics, in contrast, is almost anti-ontological. It warns that what we call reality is inseparable from the information exchanged between systems. The quantum state is not a thing but a catalogue of expectations, a bookkeeping of relations. To those who crave a solid metaphysical bedrock, this sounds like surrender. To others, it is a liberation from the false comfort of a single, ultimate being. Science and metaphysics now stand face to face. The many-worlder invokes the power of mathematical parsimony. Why add mysterious collapse triggers when the Schrödinger equation already explains everything? The collapse advocate counters that a theory that predicts infinite unseen worlds may be mathematically clean but existentially extravagant. Bohm's disciple nods toward the crisp determinism of hidden variables while accepting the strange non-local ties that bind the cosmos. The relational thinker smiles, reminding all that perhaps the very demand for a single absolute reality is a human yearning, not a cosmic truth. As arguments rise, the stage transforms into a theater of evidence and mystery. Experiments on quantum interference, Bell inequalities, and macroscopic superpositions flicker like lanterns. They confirm the predictions of quantum theory, yet remain agnostic about which script is the true one. Each interpretation survives every experimental test so far, cloaked in empirical equivalence. The data is generous enough to accommodate contradictory metaphysical dreams, yet the tension is not merely academic. These competing visions shape our sense of what the universe is and what we are within it. If many worlds is right, then every choice you make splinters reality into countless echoes, each as real as the next. You are both singular and infinitely replicated. If objective collapse holds, the universe contains a fundamental spontaneity. Reality crystallizes in unpredictable flashes, and chance is woven into the fabric of being. Should Bohmian mechanics prevail, we inhabit a deterministic cosmos where hidden currents guide every motion, where what we call randomness is but a shadow of deeper order. And if relational quantum mechanics captures the truth, then reality is not a solitary monolith, but a living network of perspectives, where existence itself is conversation. These are not mere technical disputes. They are different cosmic mythologies clothed in mathematics. They offer contrasting portraits of consciousness, free will, and the meaning of observation. Are we passive witnesses of a multiverse unfolding beyond control? Are we participants in a world whose events crystallize through genuine chance? Are we dancers in a hidden choreography of deterministic waves? Or are we nodes in an endless dialogue, our realities stitched from the threads of relation? Each interpretation beckons with a different promise. Many worlds offers the thrill of infinite possibilities, but demands we accept a dizzying ontology. Objective collapse grants a single, definite world, but asks us to believe in an unseen mechanism of reduction. Bohmian mechanics restores determinism, yet leaves us with the puzzle of instantaneous connections across space. Relational quantum mechanics frees us from the burden of absolute truth, but challenges our longing for a shared universal reality. In the end, the debate does not yield a victor. The quantum stage remains lit with multiple spotlights, each revealing a different aspect of the mystery. Perhaps this is the true lesson, that reality is too vast, too subtle to be captured by a single narrative. The interpretations are not merely rivals, they are mirrors reflecting our own philosophical desires. In their contest, we glimpse the frontier where science and metaphysics meet, where the human quest for understanding becomes a dialogue with the cosmos itself. Cosmic scales and infinite realms. Imagine standing on the shores of an endless ocean. The horizon dissolves into a mist of possibility, and every wave carries the echo of something unthinkably vast. This is the sensation cosmologists chase when they speak of the multiverse, a vision of reality that stretches beyond every conceivable boundary, where our entire universe becomes a single ripple among countless others. To venture into these cosmic scales is to step into a drama so immense that language strains to hold it, a theater where infinity itself becomes the stage. The story begins with a single, breathtaking idea: cosmic inflation. In the earliest fraction of a second after the Big Bang, space itself is thought to have expanded at a rate so violent that it outpaced the speed of light, smoothing the chaos of primordial energy into the cosmic order we now observe. Galaxies, stars, and the delicate web of cosmic filaments are the frozen signatures of that sudden growth. Inflation was not merely an explosion, but a transformation of the very fabric of space, stretching quantum fluctuations into the seeds of every galaxy that ever was or ever will be. Yet this grand mechanism, so precise and mathematically elegant, carries a consequence almost too audacious to believe. If inflation can occur once, why would it not occur again and again without end? In the equations of eternal inflation, space continues to blossom in pockets, each bubble spawning its own universe, each with its own physical laws. Our cosmos, vast beyond imagination, becomes just one chamber in an infinite cosmic honeycomb. The stars above our heads, which once seemed like the ultimate symbol of limitlessness, are reduced to a local detail in a boundless, ever-generating expanse. Here, science begins to brush against something that feels almost mythic. These bubble universes are not merely empty voids. Each could carry different versions of physics itself. Some might harbor dimensions curled so tightly that no light escapes. Others may be ruled by alien constants where chemistry as we know it cannot arise. Somewhere, perhaps, are worlds where galaxies never formed or where time itself flows in rhythms unrecognizable to us. And somewhere else, if probability stretches far enough, might be a universe eerily similar to ours, where a figure identical to you contemplates these very words beneath an alien sky. The intellectual vertigo of this vision is matched by a quiet unease. For while mathematics invites us toward infinity, our human experience remains bound to a single, intimate thread of existence. What does it mean to be one consciousness when reality may be an endless froth of worlds, each carrying other stories of you? Does it diminish the singularity of our own life, or does it amplify it, making each moment a rare jewel in the face of infinite possibility? Physicists approach these questions with both wonder and suspicion. The inflationary multiverse emerges naturally from equations that successfully explain the cosmic microwave background and the large-scale structure of the universe. Yet the same concept resists the usual methods of scientific proof. We cannot point a telescope into another bubble. We cannot bottle the infinity of space and test it in a lab. For some, this is a fatal flaw. A hypothesis that cannot, even in principle, be verified might belong more to philosophy than to physics. For others, the multiverse is simply the inevitable consequence of the theories that already describe our universe so well an inference we cannot avoid simply because it disquiets us. This tension between evidence and speculation becomes even sharper when we draw the quantum world into the cosmic stage. Quantum mechanics already unsettles our sense of reality with its many worlds interpretation. Every quantum event, it suggests, spawns branching possibilities, each as real as the one we observe. What if these quantum branches and the bubble universes of eternal inflation are not separate tales, but two expressions of a single, deeper pattern? Some researchers have imagined a multiverse of multiverses where the quantum and the cosmic interlace a vast hierarchy of realities in which our own existence is but a flicker within flickers. Such speculation courts the edge of metaphysics, and yet it is not mere fantasy. The mathematics of inflation and the logic of quantum branching share a strange harmony. Both describe reality as fundamentally generative, forever unfolding new possibilities. Perhaps in some as yet unknown synthesis, these two infinities, one born of quantum uncertainty, the other of cosmic expansion, will meet. Perhaps what we call reality is only a single octave in a symphony without end, but awe must always be tempered by caution. To speak of infinite realms is to risk slipping into poetry when we intend to do physics. Models of eternal inflation remain elegant but incomplete. Quantum many-worlds is compelling yet untested. The danger lies in mistaking metaphor for measurement, in confusing the seduction of an idea with the rigor of science. Infinity dazzles, but it can also deceive, and still the mystery endures unshaken. We look up at the night sky and see only a fraction of what might exist. The cold grandeur of inflationary theory humbles us, yet it also stirs a more intimate wonder. For if the cosmos is truly infinite, then our brief, finite lives acquire a paradoxical weight. Each choice, each fleeting moment of awareness, is both inconceivably small and yet part of something without boundary. To contemplate such scales is to stand at the frontier where knowledge meets mystery. The multiverse may remain forever beyond our instruments, but the act of imagining it transforms us. It stretches the mind beyond the confines of a single world and invites us to see our existence not as an isolated accident, but as a note in an eternal composition. In the tension between evidence and speculation, between the cold equations of inflation and the intimate pulse of human curiosity, we encounter a truth as profound as any scientific discovery, that the universe, whether one or infinite, is always larger than our certainty and richer than our dreams. The observer's dilemma, single question, has haunted the frontiers of science and philosophy for more than a century. When we look at the universe, are we merely watching it unfold, or do we, by the very act of looking help, bring it into being? Beneath this question lies the riddle of the quantum measurement problem, an enigma that has unsettled physicists and philosophers alike, and that whispers of something far larger than any laboratory experiment. Quantum theory tells us that before a measurement is made, a particle's position or momentum exists only as a haze of probabilities, a cloud of potentiality described by the mathematics of a wave function. Yet the instant we measure, the cloud collapses into a definite fact. The electron is here, the photon goes there. Why? Is this collapse a natural process, an inevitable crystallization that happens whether or not a conscious mind is watching? Or does the presence of an observer, a mind capable of awareness, play a decisive role in coaxing reality from the realm of possibility into the solid world of experience? This is the heart of the observer's dilemma. To some, it is a purely physical puzzle. The universe behaves strangely, but there is nothing magical about our act of observation. According to the Copenhagen interpretation championed by Niels Bohr and Werner Heisenberg, the wave function's collapse is not a physical event, but a change in our knowledge. Measurement simply marks the moment when we update our description of the system. Reality does what it does. We are just catching up. Others, however, sense that this answer skirts the deeper mystery. If the wave function is not just a bookkeeping device, but a real physical entity, then its sudden collapse demands an explanation. Enter Hugh Everett's many worlds interpretation. There is no collapse at all. Instead, every possible outcome occurs, each in its own branching universe. The photon goes left and right. The cat is alive and dead. We, the observers, split into countless versions of ourselves. In this picture, consciousness is not a cosmic trigger. We are passengers in a multiverse already vast beyond comprehension. Yet even this grand vision raises its own riddle. If every possibility is real, why do we experience only one? Why does our awareness seem to ride a single thread through the tangle of worlds? Everett's mathematics is silent on the felt texture of subjective experience. Physics can describe the pattern of branches, but it does not tell us why we find ourselves in this one and not another. Here, philosophy enters. Hard-nosed physicalists argue that consciousness is a latecomer, an emergent property of complex matter. The brain, sculpted by evolution, generates the illusion of a unified self. To them, mind is no more a cosmic participant than the rainbow is a cause of the storm. Neuroscience lends weight to this view. Experiments reveal how perception is built from electrical firings, how decisions can be predicted milliseconds before we are aware of making them. If neurons can foreshadow our choices, perhaps the feeling of conscious will is simply a story the brain tells itself after the fact, and yet the mystery refuses to die. Quantum phenomena such as entanglement, where two particles remain correlated across light years, tease our intuitions about separation and influence. Some thinkers, from John Wheeler to contemporary philosophers of mind, wonder whether consciousness is not merely an evolutionary afterthought, but a fundamental ingredient of the cosmos. Wheeler spoke of a participatory universe, where acts of measurement are acts of creation, and the universe comes into being through the questions we ask. He imagined a cosmic game of 20 questions in which reality itself exists only because it is continually interrogated. This idea, once dismissed as poetic fancy, has found unlikely echoes in modern debates. Theories of panpsychism suggest that mind-like qualities pervade the fabric of nature, that consciousness is as basic as space, time, or energy. Integrated information theory, though rooted in neuroscience, implies that the spark of awareness might arise wherever information is richly interconnected, perhaps even at scales beyond the human brain. If so, the sharp divide between inert matter and conscious mind begins to blur. Yet caution is essential. Claim that consciousness shapes the universe risks drifting into mysticism. Science demands testable predictions, and no experiment has yet proven that a human observer can bend the probabilities of a quantum event. The double-slit experiment works whether or not anyone is watching. Detectors alone suffice to collapse the wave function. The cosmos, it seems, does not wait for our gaze. Still, the question lingers like a half-heard melody. Perhaps consciousness does not cause collapse, yet neither is it a trivial byproduct. It may be that the very existence of minds capable of pondering the universe is itself a clue to its deepest nature. Cosmologists note that the laws of physics appear exquisitely tuned for life and mind to arise, an observation that invites both scientific explanations and metaphysical speculation. Are we simply the lucky outcome of countless cosmic rolls of the dice, or is the universe somehow predisposed toward awareness? Between these poles, strict physicalism and participatory cosmos, stretches a landscape of profound uncertainty. Each interpretation carries its own allure and its own shadows. The hard-nosed materialist vision promises clarity but risks reducing lived experience to a mere epiphenomenon. The participatory view offers grandeur but flirts with the unfalsifiable. Perhaps the true resolution lies not in choosing one side but in embracing the tension itself. The observer's dilemma forces us to confront the limits of our understanding. We are part of the very reality we seek to explain. Our instruments, our brains, and our questions are all entangled with the cosmos we measure. We cannot step outside to gain a God's eye view. This recognition does not diminish science, it deepens it. To probe the quantum world is to encounter a mirror, one that reflects both the strange behavior of matter and the mystery of our own awareness. Whether consciousness is a co-author of reality or merely its astonished witness remains unsettled, and perhaps that very uncertainty is what keeps the human spirit restless, curious, and alive to wonder. Identity across the infinite. Suppose every decision you have ever made splinters reality into a new path, one where you took the job, another where you turned it down, countless more where the smallest impulse shifted the course of a lifetime. Imagine those paths not as metaphors but as real, coexisting worlds. Somewhere, another you just glanced up from a book you never read in this universe. Somewhere else, a version of you has already taken the step you are still hesitating to take. If these other selves are as tangible as you are, then who exactly are you? For millennia, philosophers and mystics have told us that the self is a singular flame, a soul, an indivisible essence, a continuity that survives change and death. Ancient Upanishads spoke of the Atman, the eternal witness behind the shifting forms. Plato imagined an immortal psyche that remembers the realm of forms. Even modern Western thought, from Descartes' "I think, therefore I am" to personal identity theories of Locke, has leaned on the idea of a continuous subject. Whether conceived as spirit or as the persistent memory of consciousness, the self was meant to be one. Yet the multiverse, if it exists, does not bow to the comfort of unity. It whispers that every possibility branches into actuality. In Everett's many worlds interpretation of quantum mechanics, every measurement spawns a proliferation of realities. If that is true, then every choice you make is both made and unmade. Your triumphs and your failures echo in countless parallel lives. There is no single biography you can cling to. There is only a fractal tapestry of selves, each as real as the next. Consider the unsettling consequence. If there are infinite versions of you, then none of them can claim to be the original. You are not the prime edition, there is no first draft. You are simply one thread among uncountable copies, each carrying the same sense of unique experience. The feeling that I am singular may be nothing more than a local illusion, a parochial perspective produced by the limits of one universe's narrative. Memory seems like the obvious anchor. Perhaps you are the one who remembers this childhood, these conversations, these scars. But memory is merely the record of a particular branch. Your counterpart across the quantum divide remembers a different yesterday with equal conviction. The sense of continuity you cherish is real, yet it is not exclusive. It is just one island of recollection amid an endless archipelago of pasts. The philosopher Derek Parfit once argued that personal identity is not what matters most. What matters, he said, is psychological continuity, patterns of thought and character that can survive even if the notion of a single, unbroken self dissolves. In a multiverse, Parfit's insight becomes almost prophetic. If you are really a constellation of near-identical minds, then perhaps identity is not a solitary flame, but a pattern repeated like a cosmic motif. The pattern exists wherever the conditions of memory and personality reappear. You are the melody, not a single note. And yet, melody or not, there is something deeply unsettling about sharing it with infinite versions of yourself. What happens to morality when every choice is both taken and not taken? If in one branch you betray a friend and in another you remain loyal, can you take credit or blame for either outcome? If in some universe you commit a crime, is that still your sin? Responsibility seems to dissolve in the infinite. We are left with a vertigo of ethics. If every possibility occurs, does anything matter? One response is defiance. This life is the one you inhabit. Your actions here carve meaning in this branch, no matter how many other outcomes unfold elsewhere. The others are not accessible. You cannot atone for their crimes or bask in their triumphs. They are strangers who happen to share your face. You own only the choices of this moment, and their weight is undiminished. But another response is humility. If you are but one of infinite selves, the ego's claim to centrality weakens. You are no longer the singular hero of reality's story. Instead, you are part of an unfathomable ensemble, a chorus of consciousness singing every variation of the human experience. Perhaps the lesson is not despair but wonder, a recognition that your existence is a note in a boundless symphony. This tension between the intimate certainty of I and the cosmic scattering of identity has haunted both science and philosophy. Neuroscientists already question the unity of the self, pointing to the brain's modular construction, its overlapping networks of perception and memory. Buddhists long ago spoke of the self as a convenient fiction, a bundle of sensations and thoughts with no enduring core. The multiverse merely amplifies what introspection and neuroscience have already hinted. The self is a process, not a possession, yet the heart resists. Close your eyes and feel the pulse behind your ribs. There is an undeniable presence, a center from which the world is seen. Call it soul, call it consciousness, whatever the name, it feels indivisible. Even if infinite worlds replicate you, that inner vantage remains stubbornly singular. You cannot inhabit the awareness of your other selves, and they cannot inhabit yours. The mystery deepens. Is the true self the pattern, or the unshareable point of view? Perhaps both perspectives are true in different registers. On the level of physics, identity may indeed be a pattern repeated without end. On the level of experience, it remains a solitary flame, your flame burning only where you are. To reconcile these layers is to stand in the space between science and speculation, between evidence and the ineffable. Consider a thought experiment. Imagine meeting another you from a parallel universe, a twin whose memories match yours until a single divergent choice yesterday. At first, the familiarity would be overwhelming. You would recognize every habit, every secret, every cadence of speech. Yet as you speak, the differences would bloom. A changed word here, a different mood there, subtle ripples that grow with every passing moment. How long before this other you becomes a stranger? How long before you realize that identity is less a fixed entity than a river that never flows the same way twice? Now stretch that encounter across infinity. For every you that chooses one path, there are countless others who chose differently. Some are only slightly altered, others radically transformed. Some live lives you would admire. Others inhabit nightmares you can. Each of them feels as real and singular as you do. Each of them says I with the same unshakable conviction. This is the existential vertigo of the multiverse, the self diffused across worlds, multiplied beyond reckoning. You are both many and one, a chorus and a solo, a pattern and a perspective. The old idea of an unbroken soul may still whisper its comfort, but the infinite cosmos invites a more daring possibility that identity is not a fortress but a field, not a single thread but a vast and shimmering weave, and in that realization lies both disquiet and liberation. You are no longer imprisoned in the narrow corridor of a single fate. Every potential you can imagine has, in some corner of reality, already been explored. You are not merely the sum of your choices, you are the spectrum of what it means to be you. So when you wonder, late at night, whether you are more than the story you tell yourself, consider the boundless theater of possibilities where your other selves are living out every narrative. Some will mirror your virtues, some will reveal your shadows. Together they form the full geometry of a life too vast for any single universe to contain. In the hush between one thought and the next, listen. The multiverse hums with the echoes of your countless selves. They are not you, and yet they are. Their existence does not diminish your own. It magnifies the mystery of what it means to be a self at all. Free will in a branching cosmos. Imagine standing at a crossroads where every path you might take is already taken by you. In one direction, you turn left and your life unfurls in a particular pattern. In another, you turn right and a different destiny unfolds. In the landscape of quantum physics, the many worlds interpretation suggests that such choices are not hypothetical, but literal. Every decision, every flicker of possibility might splinter reality into countless versions of you. If every option is realized somewhere, does the concept of free will evaporate like morning mist, or does it gain a new paradoxical depth? The question has haunted philosophers for centuries. Ancient Stoics accepted a universe ruled by inexorable fate, where freedom resided not in altering events but in mastering one's inner response. Centuries later, Enlightenment thinkers defended a more defiant liberty, the belief that human agency could bend the course of history. And yet, as modern physics peeled back the veil of the cosmos, the ground beneath these debates shifted. The quantum realm introduced a kind of indeterminacy that classical mechanics never allowed. But indeterminacy is not the same as freedom. A coin flip is unpredictable, but no one imagines the coin is free. Libertarian philosophers of free will argue that true freedom demands the capacity to have genuinely chosen otherwise, a power unbound by deterministic chains. But if the universe forever splits, ensuring every alternative is enacted somewhere, what becomes of this otherwise? You might think that such branching secures the very possibility libertarians crave. After all, somewhere you did choose differently. Yet this abundance of outcomes threatens to drain any single act of its weight. If all decisions are realized, what meaning attaches to the one you consciously embrace? Determinists counter that free will has always been a mirage. Whether the universe unfolds like clockwork or like a quantum kaleidoscope, your sense of agency is simply the mind's narrative overlay on processes beyond your control. From Laplace's demon to the equations of Schrödinger, the cosmos can be seen as a grand computation, its future inscribed in its present, even if we can never compute it. Under this view, the many worlds interpretation merely reframes determinism. Every branch was implicit from the start. The script is vast, but the script was always there, and yet experience rebels. When you stand before a difficult decision whether to confess a secret, to leave a career, to forgive a betrayal, your choice feels neither trivial nor pre-written. It feels like a pivot point, a moment where something genuinely emerges from the depths of possibility. Neuroscience complicates this intuition. In landmark experiments, researchers like Benjamin Libet measured subtle electrical patterns in the brain, readiness potentials that anticipate a subject's decision fractions of a second before the person becomes aware of deciding. If your brain has already prepared your action before you decide, is the conscious self merely a spectator? Critics of these experiments caution that milliseconds of neural priming do not equate to destiny. The brain may prepare multiple pathways in parallel, awaiting a final veto from conscious attention. That veto, subtle yet decisive, might be where freedom hides. Chaos theory reinforces this glimmer of autonomy. In systems exquisitely sensitive to initial conditions, such as weather patterns or the turbulent swirl of galaxies, tiny fluctuations produce colossal effects. If the mind is a dynamical system of this sort, then microscopic variations down to the quantum level could cascade into unique acts of will. Determinism might still rule the equations, but prediction becomes impossible. And in the space of that unpredictability, our sense of choice breathes. The tension between determinism and freedom intensifies when seen through the lens of quantum branching. Each fork in the cosmic road embodies every possible decision, yet within any single branch you inhabit, the outcome still matters. From your own perspective, you do not live all the lives of your duplicates. You live this one. The other versions are inaccessible, ghosts of alternative histories. In that isolation, meaning is not dissolved by multiplicity, but sharpened by it. The fact that other yous chose differently does not render your act meaningless. It underscores the singularity of your conscious thread. Some philosophers describe this as a perspectival freedom, not the power to alter the grand total of all branches, but the capacity to own the story unfolding in the one you experience. Your agency lies not in collapsing the multiverse and impossibility, but in embracing the path you perceive. This is not a retreat to mere illusion. It is a recognition that freedom may be relational rather than absolute, born in the interplay between a mind aware of possibilities and a world that forever hides most of them from view. In this light, free will becomes both constrained and mysteriously resilient. The constraints are obvious. Physics sets the stage, biology furnishes the machinery, and countless hidden factors nudge your thoughts and actions. Yet resilience emerges from the very complexity of these constraints. The branching cosmos does not trivialize your choices. It renders them part of a larger, incomprehensible pattern where each conscious decision is a moment of creative selection, an act that shapes the narrative of a single world line. Spiritual echoes and ancient intuition. Across the shifting frontier where physics and philosophy meet, a quiet resonance hums like an ancient bell, faint yet unmistakable. The multiverse, a concept born in the equations of modern physics, seems startlingly familiar when we listen to the echoes of humanity's oldest spiritual musings. It is as if the idea has been whispering through the corridors of time, wearing many names and forms, waiting for a language of mathematics to catch up with the intuitions of sages. Long before quantum theory cracked open the doors of possibility, Buddhist cosmologies spoke of countless world systems, realms layered like reflections in a boundless sea. These were not merely decorative myths, but visions of reality without a single center, without finality, worlds blooming in number beyond the grasp of any single mind. In the Pali Canon, universes arise and dissolve in cycles of unimaginable scale. In Mahayana thought, infinite Buddha fields shimmer beyond the reach of any telescope. These descriptions, composed centuries before the first scientific revolution, read like poetic anticipations of today's most daring physics. Mystical traditions across cultures also carried a similar intuition. From the shimmering plurality of Hindu cosmology to the Kabbalistic notion of layered worlds, from the Sufi visions of multiple realms of being to the Neoplatonic ascent through hierarchies of existence, the story repeats. Reality refuses to be bound by a single plane. These traditions were not measuring with instruments or seeking proof by experiment. Yet their metaphors, dreams within dreams, reflections of reflections, hinted at a reality vaster than ordinary perception. Modern physics approaches the same mystery with a radically different discipline. Here, speculation is tethered to equations, and the imagination is bound to the rigors of mathematics. The multiverse emerges not from revelation, but from the logical consequences of theories like inflationary cosmology and quantum mechanics. String theories, extra dimensions, and the many worlds interpretation of quantum mechanics both gesture toward a profusion of realities, an elegant, if unsettling, consequence of the very laws we trust to describe the cosmos. For scientists, these are not parables but mathematical imperatives. Evidence remains elusive and debate fierce, yet the patterns their equations describe resonate strangely with those ancient intuitions of limitless worlds. This convergence does not erase the distance between science and spirituality. The Buddhist texts do not predict quantum branching, and the many worlds interpretation does not sanctify enlightenment. What unites them is subtler, the shared recognition that reality may be larger, stranger, and more inexhaustible than the human mind can domesticate. Where the mystic speaks of infinite realms and the physicist calculates an infinity of universes, both are confessing to a common awe the intuition that existence is too vast to be captured in a single narrative. Contrast sharpens the picture. The scientist insists on evidence, the mystic on experience. One builds models, the other seeks transcendence. Yet their very differences become complementary. Where spiritual traditions risk dissolving into dogma, science demands verification and doubt. Where science risks reducing mystery to mechanism, spiritual imagination restores depth and wonder. The tension between them prevents complacency. It forces the question, can the human spirit thrive on reason alone, or does it require the symbolic language of myth to approach the infinite? This tension also reflects an older truth about human curiosity. Our species has always strained toward horizons we cannot fully see. From ancient temples aligned with the stars to the particle accelerators buried beneath the earth, the gesture is the same, a longing to grasp the ungraspable. The multiverse, whether as metaphor or hypothesis, becomes a mirror of this drive. It embodies both our appetite for explanation and our recognition that ultimate reality may forever escape final capture. Consider the way modern cosmologists speak of bubble universes, regions of space-time each with its own laws and constants. The image is hauntingly close to the Buddhist vision of innumerable world systems, each rising and fading in the endless play of cosmic impermanence. The parallel does not imply that ancient monks secretly anticipated inflationary theory. Rather, it shows that when humans contemplate the boundless, our minds return again and again to similar archetypes. Infinity, it seems, wears many masks, nor is this resonance limited to the East. In medieval Europe, the philosopher Nicholas of Cusa speculated that the universe is a sphere whose center is everywhere and circumference nowhere. Centuries later, Giordano Bruno dared to proclaim an infinite cosmos with innumerable worlds, a vision so heretical it cost him his life. Today, physicists debating the landscape of string theory echo, unwittingly, these bold intuitions. The difference lies in method, not in the depth of wonder. Such echoes invite both caution and curiosity. It would be tempting to claim that ancient wisdom anticipated modern science, to fold quantum theory neatly into timeless prophecy. But that temptation flattens both traditions. The integrity of science lies in its self-correcting skepticism. The vitality of spirituality lies in its capacity for metaphor and transformation. To conflate them is to lose the distinctive power of each. Better, perhaps, to let them stand in dialogue, a conversation across millennia, each challenging the other to see more deeply. And yet, when we allow these voices to mingle, something luminous emerges. The multiverse ceases to be a sterile abstraction of equations and becomes a living idea, a bridge between the measurable and the ineffable. It awakens the same vertigo that the mystics once felt gazing into the night sky, the same trembling awareness of realities beyond the reach of ordinary sight. Here, the language of science and the poetry of spirit converge not in certainty, but in wonder. Wonder itself may be the true common ground. For whether we speak in the idiom of quantum mechanics or the chants of ancient monasteries, we are responding to the same call, the universe's invitation to marvel. In that shared reverence, the multiverse becomes more than a theory or a myth. It becomes a reminder that human understanding, no matter how refined, is always provisional, always leaning toward a mystery it cannot contain. This is not a surrender to unreason. It is a recognition that reason itself flourishes at the edge of the unknown. Science thrives on questions that lead beyond current knowledge, just as spiritual insight thrives on the silence beyond words. The dialogue between them does not resolve the enigma of existence, but deepens it. And in that deepening, we glimpse the vast, uncharted expanse where our oldest intuitions and our most advanced theories meet, like two mirrors reflecting one another without end. Doubt, critique, and the limits of knowing. There is a certain hush that settles when the lights of wonder fade and the questions sharpen into something colder. The many worlds interpretation, for all its daring elegance, walks into this hush like a figure stepping onto thin ice. We have followed its story through branching universes and shimmering possibilities, but now we arrive at a crucible of skepticism, the realm where bold conjecture meets the flint of scientific discipline. It begins with a simple, uncomfortable question: how would we ever know? For critics, this is the fulcrum. The many worlds hypothesis, they argue, offers no experimental signature that distinguishes it from the standard quantum formalism. In laboratories from Geneva to Pasadena, detectors register the same telltale clicks whether one believes in a single cosmos or an infinite quilt of realities. If every possible outcome exists somewhere, what could possibly count as evidence for or against it? The silence of the measuring instruments, identical in every branch, is not a neutral silence, it is a damning one. Philosopher of science Hilary Putnam once warned that a theory without a conceivable test is not merely incomplete, it is, in a strict sense, outside the practice of science. To him and others, the many worlds interpretation is less a physical theory than a metaphysical flourish, a kind of intellectual art. Its equations may be impeccable, but so are the equations of any number of elegant mathematical fictions. The critic's voice is steady, physics is not poetry, and the demand for falsifiability is the gate that keeps speculation from becoming mere dream. And yet, defenders of many worlds answer with an equally steady gaze. They insist the accusation of unfalsifiability is misplaced. The theory, they argue, does not bolt new machinery onto quantum mechanics. It simply takes the mathematics we already trust, the Schrödinger equation, and reads it without the arbitrary postscript of collapse. To them, the burden of proof lies not with those who follow the math to its logical end, but with those who insert a mysterious wave function collapse simply because the consequences of not doing so are vertiginous. In their eyes, the critics are the ones adding an untested hypothesis, not the other way around. This is the duel at the heart of the debate. Is many worlds a reckless metaphysics? Or is it the purest form of physics merely refusing to avert its eyes from the implications of the equations? Between these poles stands the restless audience of science itself, torn between two instincts. One is the hunger for grand explanations, the yearning to glimpse the ultimate architecture of reality. to know what truly is beyond the fragile curtain of measurement. The other is the stern discipline of empiricism, the quiet but unyielding demand that a scientific claim must, at least in principle, face the tribunal of experiment. The contrast is not merely academic. It touches something primal in the human spirit, our double allegiance to wonder and to proof. We are by nature dreamers and doubters. When the dream grows too vast to measure, the doubter steps forward. And when doubt threatens to choke the dream, the seeker of wonder breathes life back into it. The many worlds debate is a mirror held up to this tension. Consider the counter voices from the philosophy of science. Karl Popper, whose famous criterion of falsifiability shaped modern scientific thinking, might have found in many worlds a cautionary tale. If no conceivable observation could disprove it, is it science or is it metaphysics draped in scientific language? Popper himself admitted that some theories begin as metaphysical programs and later become testable, but until that day arrives, they dwell in a twilight zone. For the critics, many worlds remains in that twilight, a spectacular speculation awaiting the dawn of evidence. But even among philosophers, there is nuance. Some argue that the demand for a single, decisive experiment is a relic of a simpler era. They suggest that science often moves by inference to the best explanation, where coherence and simplicity count as evidence of their own kind. To them, many worlds offers an unmatched conceptual economy, no special collapse postulate, no hidden variables, just the raw mathematics of quantum theory. It may be untestable today, but so once were black holes, whose existence was inferred long before a telescope captured the ring of fire around their shadow. This is where the debate folds back on itself like a Mobius strip. To reject many worlds for lack of direct falsifiability is to impose a certain philosophy of science, one not universally shared. Yet to embrace it on grounds of elegance alone risks dissolving the boundary between science and metaphysics. The tension is not a flaw in the discourse, it is the discourse. Physicists themselves are not immune to this ambivalence. Some, like Nobel laureate Steven Weinberg, confessed admiration for the mathematical purity of many worlds while remaining cautious about its physical import. Others dismiss it outright as a cheap solution, a fantasy of infinite duplication that explains nothing because it explains everything. Meanwhile, a growing cadre of quantum information theorists finds the formalism almost unavoidable. For them, the Everettian picture is not an indulgence but a natural consequence of treating quantum states as objective information. Through interviews and papers, one hears the subtle music of doubt and defense. A critic points to the absence of an experimental lever. A defender counters that no rival interpretation provides a cleaner ontology without hidden mechanisms. A philosopher notes that our very notion of test evolves with the tools of science. What was once untestable becomes, with technological daring, a laboratory reality. The dialogue is not a standoff, but a slow, spiraling dance. Underlying all these arguments is a deeper unease. Perhaps the universe does not yield all its secrets to the methodology we call science. Perhaps some questions, like whether countless parallel worlds shimmer beyond our perception, live forever on the threshold of knowing. This is not a counsel of despair. It is a recognition of the limits that make inquiry meaningful. Without the edge of mystery, knowledge itself would lose its urgency. It is tempting to believe that with enough ingenuity, every hypothesis can, sooner or later, be tested. History offers encouragement. Gravitational waves, once a theoretical ripple, now sing through detectors. Quantum entanglement, once derided as spooky action, now underpins entire technologies. Yet history also humbles. The question of why there is something rather than nothing remains untouched by data. The riddle of consciousness defies the scalpel of experiment. Some frontiers are not merely distant, they may be constitutive of our finitude. Many worlds poised between these categories is both a challenge and a lesson. It reminds us that science is not merely a catalogue of measurements, but a human enterprise shaped by philosophy, by taste, by the courage to imagine, and the discipline to doubt. The critic's charge of metaphysics is not an insult, but an invitation to clarify what we mean by knowledge, to examine the rules by which we grant a theory the badge of science, and so we stand at the boundary. On one side, the intoxicating vision of infinite realities, each as real as the world in which you read these words. On the other, the sober call for evidence, the insistence that truth without test is a story awaiting its proof. Between them stretches the narrow bridge of human reason, fragile, contested, and luminous. To walk that bridge is to inhabit the very tension that makes inquiry profound. Doubt is not the enemy of wonder. It is its necessary companion. Critique does not diminish mystery. It gives it shape. And the limits of knowing are not walls but horizons, reminding us that the universe is not merely a puzzle to be solved, but a vastness to be approached with both awe and humility. In this sober light, the many worlds interpretation becomes more than a speculative claim. It becomes a mirror of our own quest, a reminder that to seek the deepest truths is to accept with open eyes that some truths may always elude our grasp. The paradox within living with infinite possibility, we live our days hemmed in by limits. Our bodies age, our moments pass. Our choices seem to close more doors than they open. Yet, in the quiet spaces between thought and observation, modern physics whispers something almost unbearable, the possibility that reality is not singular, but endlessly branching. Each decision, each quantum flicker might bloom into a separate universe, a web of existence so vast that our own life becomes only one thread among uncountable others. This vision is both liberating and disorienting. For if the cosmos contains infinite world, then every version of you that can exist does. Somewhere, perhaps you have already taken every road you once feared to travel. Somewhere, you have never been born. The multiverse is not just a concept, it is an invitation to reimagine the scale of what it means to be alive. But the invitation carries a tension. How do we cherish the fragile singularity of our days when we are told that reality may be infinite? Science approaches this mystery with equations and probabilities, charting the mathematics of quantum superposition and cosmic inflation. Philosophy, meanwhile, asks what it means for meaning itself. If there are infinite variations of every life, does significance dissolve into statistical noise, or does it deepen because every moment is echoed across endless realities? Some argue that our choices lose weight if all possibilities are realized. Yet, the very fact that we can wonder here and now gives this particular thread a kind of gravity no other can replicate. The humility of our finite existence sharpens in the face of such immensity. We are small not only in space and time, but in possibility, and yet that smallness does not diminish us. It invites reverence. A single breath, a single glance becomes a marvel precisely because it is this breath, this glance, unrepeatable in the consciousness that knows it. Infinite worlds may contain infinite versions of the moment, but none can steal the uniqueness of the awareness that experiences it now. Consider the contrast, the physicist's laboratory where particles dance in probabilistic clouds, and the quiet interior where a human heart beats knowing its own mortality. The scientist measures, the seeker feels. Evidence demands precision, yet the mystery refuses closure. We live suspended between what can be calculated and what must be contemplated. It is here, in this tension, that wonder thrives. Doubt and belief coexist like twin stars. We doubt that we will ever glimpse these hypothetical worlds. We believe, perhaps secretly, that reality is vaster than our senses reveal. The paradox is not something to solve, but something to inhabit. To live with infinite possibility is to accept that certainty will always be partial. It is to recognize that knowledge itself is a horizon forever receding, and that our longing to know is part of the cosmos waking to its own question. This recognition reshapes the meaning of a single life. If reality is a boundless branching of worlds, then our choices are at once monumental and modest. monumental, because in this universe they sculpt the only life we will ever directly experience. Modest because elsewhere other selves have chosen differently, and the cosmos carries on. Responsibility remains, but it is no longer about clinging to a single outcome. It is about inhabiting the moment fully, aware that the moment is both everything and one among countless echoes. Such awareness does not numb us. It deepens our capacity for wonder. The night sky ceases to be merely distant fire. It becomes a mirror of possibility, a map of questions that no final answer can silence. And when we feel the pull of mystery, when we sense that the universe is stranger than any story we can tell, we participate in something larger than comprehension. We become the place where the universe contemplates itself. To stand in this awareness is to be both fragile and infinite, a finite creature carrying the whisper of endless worlds. We do not need to solve the riddle. We need only to live it, to breathe, to question, to marvel, and to let the ungraspable widen the boundaries of our own hearts.